Hello and welcome to another SHSAT review. Today I'm going to be reviewing, I think, 12 geometry problems for the 2020 SHSAT Student Handbook. Link is in the description. We're going to be starting off with question 61, Form A. In the figure above, line L is perpendicular to line N. What is the value of X? Okay. So you know L is perpendicular to N, so they form a 90-degree angle. This is now a 90-degree triangle. And we want to find the value of this angle, which is x. So we can just solve for the various angles of the triangle. So you have, notice x and 35 are vertical angles, which means we can rewrite x over here, and we could rewrite 35 over here. There's an x shape. This angle is going to be equal to this angle. This angle is going to be equal to this angle. Same goes here. It's just a rule. So now that we have angles inside of a triangle, we can solve for x. We know that the total sum of all angles in a triangle is 180, so we can write 90, because it's the right angle, this equals to 90 degrees, plus 35 degrees, which we transposed here, vertical angles, plus x, which we transposed here because of vertical angles, is equal to 180. 90 plus 35 is equal to 125. 125 plus x is equal to 180. Subtract 125 from 180. 180 minus 125 is 55, so x has to be 55 degrees, which is the correct answer. Moving on to question number 82. 73, 79, and 82 should be right here. Okay, so we have a similar lines J and K intersect at point Q. H is a straight line. H is a straight line. What is the value of x? Okay, so we have a similar problem to our first problem. Right here, what can we ascertain? We can ascertain that x is a vertical angle, so we'll transpose x on the inside. And we could also see that 100 is a vertical angle, so we can write it here. But in order to solve x, we need this angle, which is missing. Remember that they said h is a straight line. And a fun property of a straight line is that it's always equal to 180 degrees. So h is equal to 180 on the bottom. It's equal to 180 on the top. So technically, 135, this angle plus 135 has to be equal to 180 in order to make h a straight line, which it is. So in order to solve for this small angle, we have to do 135 plus x is equal to 180. We can subtract 135 from both sides. And I'll tell you 180 minus 135 is equal to 45 degrees. So we know x is equal to 45. Let me just zoom in here to make it easier to see. So we know that this angle is 45. Now, the same property we did, we know all of this is equal to 180, so we can do 100 plus 45 plus x is equal to 180. 145 plus x is equal to 180. We can subtract 145. 180 minus 145 is equal to 35, so x has to equal to 35 degrees, which is our answer. Let's zoom out a little bit. Okay. Let me check. Moving on to number 91. And right here. Okay, in the parallelogram above, what is the value of x plus y? Well, one property of a parallelogram is that these two are parallel, but that's kind of irrelevant. And these are also parallel, but that's also relevant. That's something you'll learn in 9th grade. It's just a fun fact. But an important property that you will learn is that opposite angles are congruent, meaning that they're equal. So angle P, which is 56, is going to equal to angle R. So if they're equal, and this one is equal to 56, this one also has to equal to 56. That also means that x has to equal to y. So now we can solve. An also thing to note is that if it has 4 sides, if it's a quadrilateral, the total internal angle value is going to be 360. So we can solve. We can do 56 plus 56 plus 2z. Let's just say that x plus y is equal to z. Sorry, it should not be 2z. x plus y is equal to z. Let's just say that. That way we don't have to write two variables. And all of this is equal to 180. Sorry, all of this is equal to 360. I'm so used to triangles at this point. Alright, so 56 plus 56 is equal to 112. 112 plus z, which is x plus y, is equal to 360. We can subtract 112. Sorry, I don't know why I wrote plus z. I'm a mess today. Alright, so 360 minus 112, that's equal to 248. So z is equal to 248. Remember, we said z is equal to x plus y, so it has to be 248. The major takeaway is that opposite sides are congruent, which means that x plus y x and y are going to be equal to each other, so you can write them as one variable. You can write the sum of them as one variable, which we did with z. I hope you understand that. Moving on to number 94. Right here. The shaded sector of a circle shown above has an area of 18 pi square feet. What is the circumference of the circle? They don't really give us a lot of space to work in, which really sucks, but basically this is equal to 18 pi. Now, this is a small sector of a circle, all right? And we know that the total internal degree measure of a circle is equal to 360. So, in order to find the circumference, we really need to find the total area of the circle. So we want to know how many of these small shaded segments will give us the entire circle. So how many times do I have to how many of these do I have to put together in order to get a full circle? So that's our step one. How do we do this? Well, we know the internal angle is 360, so we can do 360 divided by 45, and that gives us 8, which means that we have to repeat this segment 8 times. So one over here, 1, 2, 3, 4, 5, whatever, 8 times in order to get the total area, which means that we have to multiply 18 pi times 8. This gives us 144 pi, which is the total area. Now we can solve for the circumference. So the formula for circumference is 2 pi r. So we need to find the radius. And we can solve this by putting our area into the area formula. So we can do 144 pi is equal to pi r squared. Because we plugged our r value into this value in order to get the total area. So this is the area of a circle formula, and this is our area of the circle. Now we can solve for r. So we can divide both sides by pi, and we get 144 is equal to r squared. We square root both sides. The square root of 144 is equal to 12. So you know your radius is equal to 12. Now that we have that, we can do 2 times 12 times pi, which is equal to 24 pi feet, our circumference. First, we found how many, an overview of what we just did, we found how many of these little pizza slices fit into the whole circle. Then we figured out the radius from that entire area, and then we plugged our radius into the circumference formula right here to get 24 pi. It's a multi-step equation. Don't get lost, don't get confused. And finally, moving on to 102 and 106. And right here. Okay, in the diagram shown above, the line segment RS is intersecting a rectangle. What is the measure of angle Y? Okay, so this is a rectangle, so we know every single angle is going to be a right angle. And we also know, since they are right angles, since they're perpendicular to each other, this line is perpendicular to this line because they form a right angle. The measure of this line is straight, since they're perpendicular, and that means that this is 180 degrees, which means that let me zoom in, that this 130 plus x is going to give us 180 degrees. This is going to be 50. Essentially what we're going to do is we're going to solve for one of the lines. We're going to solve for this. So we know that y plus an unknown value is going to give us 180. So that's how we're going to solve. And remember that this angle that we want to find is going to equal to this angle right here because they're vertical angles. So we can do 50 plus 90 is equal to plus x is equal to 180. So essentially, here's our plan. Here's our plan for the entire to find this. Sorry if it's a little confusing. We know that this is a 90-degree angle, and we know that y plus this value is going to equal to 180. So if we find this value, we can also find y. And we know that this value is a vertical angle, so we can write this value here as an unknown angle. Okay? Then we also know that 130 plus this internal value is going to equal to 180. 130 plus 50 is equal to 180. And we also know that this is 90 degrees because in a rectangle, everything is equal to 90 degrees. So we can write our formula 50 plus 90 plus x is equal to 180. That's 140 plus x is equal to 180, I think. Yeah. And then x has to equal to 40 degrees. So this is now 40, and this has to be 40. So now y plus 40 is equal to 180. What plus 40 is equal to 180? Well, 140 plus 40 is equal to 180, which is E. And that is our answer. Hope you understood that. Once again, these are not complicated problems. They just involve a lot of steps and a lot of specific rules that you have to memorize. And one of the best rules to memorize is that straight lines is equal to 180 degrees. If two lines are perpendicular, they must be straight. And you have to remember vertical angles. So when two lines intersect at a point, their opposite angles are going to equal to each other. So angle 1 is equal to angle 2, angle 3 is going to equal to angle 4. And this entire segment is going to equal to 360 degrees. It's another rule. So now we move on to number 106, and then we'll be done with Form A. 106. In the figure above, the shaded rectangle is similar to the outer rectangle. The length of the outer rectangle is 4 feet, and the perimeter of the outer rectangle is 14 feet. If the width of the shaded rectangle is 2 feet, what is the area of the shaded rectangle? Okay, so you know they're similar, which means that there's a scale factor, meaning that there's going to be a magic number that we can multiply 4 feet by in order to get this length. And there's going to be a magic number we can multiply 2 feet by to get this length. But we don't need that so far. So far, we know that the length of the outer rectangle is 4 feet. If this length is 4 feet, this also has to be 4 feet. We also know that the perimeter is going to be 4 feet. So this side plus this, and this is equal to 14. That's 4 plus 4 plus 2x, this side is going to be x, is equal to 14. That's 8 plus 2x is equal to 14. 2x is equal to 6, x is equal to 3. You know that this side, you know that this side is equal to 3, and this side is equal to 3. And this is all that we have to solve for. It's all the information we need to solve. So recall that we said these are similar, which means that there's a magic number that we can multiply 3 by to turn it into 2. And essentially, we do that by dividing 3 by 2, which is the same thing as saying 2 over 3. And if we multiply 3 by 2 over 3, we'll get 2. Let's test it out. 2 times 3 is equal to 6. 6 over 3 is equal to 2. Yeah, so our scale factor is going to be 2 over 3 in order to go from big to small. If we wanted to go from small to big, if we wanted to go this way, we'd flip it around and it'll be 3 over 2. And that's it. So now that we know our scale factor, this will apply to all sides. Our 2 over 3 will apply to all sides of the big rectangle. So we want to find this. We want to find the area, so we need to find this. So I'll multiply 4 times 2 over 3, which is our scale factor. That'll give us 8 over 3 as this. This side is 8 over 3. And we want to find the area, so we'll multiply this by 2, because it's length times width. LW, length, width, we'll multiply them together. We get 16 over 3. What's the closest number that, and then we can simplify this. What's the closest number, what's the closest physical oh god, this is... Well, what times 3 is close to 16? 5 times 3 is close to 16, so we can write 5. 3 times 5 is 15, which leaves us 5 1/3, which is this. Way to check it, we can multiply 5 times 3, which is 15, and add 1 to it, which would be 16 over 3. If you're taking the 9th grade SHSAT, you should already know how to simplify things, so sorry if you had trouble understanding that last part, but that's it. Moving on to Form B, and we're going to be on question 73. SHSAT geometry is not really hard. Same thing for 9th grade geometry. They're just a bunch of formulas and rules that you have to memorize. And same thing for regular high school geometry that you'll have to probably take next year. So it's nothing really to worry about. It doesn't get too complicated. 73, which is right here. A wheel has 15 spokes equally spaced. What is the measure of angle between adjacent spokes? Okay, so it's a circle, right? One of the properties we talked about was the total internal angle of a circle is 360. And if we have 15 of them, the internal angles of all of these 15 are going to be equal to each other because they're equally spaced. So 360 is equal to 15x. 15 spokes, x is the internal angle of all of these spokes. And we can do that because they're equal. And we can combine them all as one term because they're equal. So now we have to solve for 15, so we'll do 360 over 15, which gives us 24. So we know that each one of these are 24 on the inside. Cool. Now we move on to number 75. Number 75. Let's zoom in on this because I'm going to have to draw on this. The diagram above shows a rectangle with an inscribed triangle. The rectangle's vertex and base touch the sides of the rectangle as shown. What is the total area of the shaded portion? Okay, so in order to find the shaded portion, we want to take the total area of this rectangle, which is this, and subtract it from the total area of this triangle. So let's do that. So automatically they tell us that the vertex of the triangle, which is the tip, touches the length of the rectangle, which means that 16 is our height. So we could just rewrite 16 right here. But notice we can't really do anything meaningful with this number because that's not how we find it. We need what we need to basically do is split this into two triangles. So this is 2 and this is 2. And this is going to be 16. So we split it up into two triangles, and now we can actually solve, now that we have base length and there's a 90 degrees. So what is the area of our triangle equal to? That's base height divided by 2. So 16 times 2, which is 32, divided by 2 is equal to 16. So the area of one of these triangles, the area of half of this triangle is equal to 16, which means the other half of the triangle is also gonna equal to 16. So now we have 16 and 16. One half is equal to 16, other half is equal to 16. We can add them together to get the total, which is 32. So if the total area of the triangle is 32, and we're following our plan, we just need to subtract 32 from our total area, which is 8 times 16. 8 times 16 is going to be 128. 128 minus 32 is going to equal to 96. I'll show you which answer choice that is. Zoom out. 75, 96 is C. So, right here. Cool. 97. And here we are. 95, 98, 97. Angle A and B are complementary. If the measure of angle B is 3 times as great as the measure of angle A, what is the measure of angle B? Okay, so a thing to know is that complementary, or comp, is equal. It means that they're equal to 90 degrees. So A plus B is equal to 90 degrees. Now we know that if the measure of angle B is 3 times as great as angle A, so B is equal to 3A, and A is equal to A. So we know that 3A plus A is going to equal to 90 degrees. We have 4A is equal to 90. A is equal to 22.5. If we divide 4 by 90, we'll get 22.5. So we know that angle A, since we put everything in terms of angle A is going to be 22.5. But remember that angle B is 3 times as great, so we'll multiply 22.5 times 3, and we'll get 67.5. Major takeaway, complementary is equal to 90, supplementary is equal to 180. Always remember that. And moving on to number 106. 106 right here. A rectangular swimming pool of uniform depth is 20 yards long, 14 yards wide, and the water is 6 feet deep. What is the volume of the pool? Okay, so we have a rectangular pool. It's basic pool. There you go. So it's 20 yards long, 14 yards wide, but look, 6 feet deep. Feet, yards. So we have to convert everything either to feet or to yards. Since they want it in cubic yards, I'm gonna convert feet into yards. So we know that 1 yard is gonna equal to 3 feet. So x yards is gonna equal to 6 feet. You can cross multiply. You get 6 is equal to 3x. X is equal to 2 feet. So now we can solve by doing 20 times 14 times 2, because volume is equal of a rectangular prism is equal to LWH, length, width, and height. Length, width, height. 20 times 14. 20 times 14 is equal to 280. 280 times 2 is equal to 560. So 106 is 560. Moving on, next problem is 109. 109 is right here. The garden design above is created in the shape of three semicircles whose diameter lie on the surface of an equilateral triangle. If each diameter is 2 meters long, what is the perimeter of the garden? Okay, so this is an equilateral triangle, which means this is 2, this is 2, and this is 2. And this is the diameter. So recall our circumference formula. Our circumference is equal to 2 pi r, or circumference is equal to pi times diameter. So pi times diameter, we know the circumference is equal to 2 pi. Note that this circumference is actually equal to the whole circle, not a semicircle. So if we want to find the circumference of a semicircle, we have to divide this by 2, which is equal to 1 pi. And since all of these have the same diameter, they're going to have the same circumference. So the perimeter of this semicircle is going to be 1 pi. This is going to be 1 pi, and this is going to be 1 pi, which is equal to 3 pi. I think they tried to trick you. A lot of people would just say, oh, well, 2 pi r or pi d, it has to be 2 pi, and then there's 3 of them, I have to multiply by 6. You get 6 pi, that's wrong. Always pay attention. Things like this are just careless mistakes that people get wrong and they get points taken off from. So, final question, I think it's 109. No, we just did 109. 113. Okay. Lines S and T intersect at point P, which is 3, 5. What is the area in square units of the shaded region of the graph above? Okay. So, there's no way of finding the area of this, like from any formula. So what we can do is what we did in our previous problem. We can take the area of this entire rectangle, and we can subtract it from the area of this triangle and this triangle. Essentially, we have it's like a cookie cutter. We have a mold and we cut it out in order to find the area of that. So we know that this is this is 1, 2, 3. That's 3. And this is 1, 2, 3, 4, 5, and that's 5. So 3 times 5 is equal to 15, and 15 is our total area. So we're going to be subtracting things out of 15. Now it's time for our two cookie cutters, which one's going to come right here, other's going to come right here. So this is our first cookie cutter. This is 1, 2, 3, 4. This is 4, and this is, if we continue this up, that's 1, 2, 3. So 4, the width is 4, length is 3, or however, base is 4, height is 3, whatever you want to say it, whatever you want to call it. So 4 times 3, recall area is LW over, base height over 2. 3 times 4 is 12. 12 divided by 2 is 6. So this is 6. This is 1, 2. So base is 2. Height is going to be 5. 2 times 5 is 10. 10 divided by 2 is 5. Cool. So we have 6 plus 5 plus x is equal to 15. 11 plus x is equal to 15. X is equal to 4. So the area has to be 4. Whenever you have a graph and you're given coordinates and there's some unusual shape, essentially you want to subtract something from something. You want to make essentially like a cookie cutter mold. You want to take away from the whole thing and you want to shape the small thing by taking away other shapes, if that makes any sense. 113 was our last problem. I hope you learned something from this video. Please leave in the comments what other subjects you would like me to cover next time. Thank you for watching and have a good day.